Hello students, welcome back to Future Foundation. Students, in today's class of basics, we will discuss point number 7th, which is cross multiplication rule. So let's start the class. So write down the heading, cross multiplication rule. In this, students, let us first consider two homogeneous equations in three unknowns. Let two homogeneous equations in three unknowns, that is a1x plus b1y plus c1z is equal to 0, a2x plus b2y plus c2z is equal to 0. So these are two homogeneous equations in three unknowns. Now if I divide z both sides, then it will become a1 times xyz plus v1 times yyz plus c1 is equal to 0, and a2 times xyz plus b2 times yyz plus c2 is equal to 0. Now students, if we consider these two equations in two unknowns, and two unknowns here are xyz and yyz, then we can solve these two equations in an ordinary method. Say one of the methods is elimination. So if I use that method, and for that purpose I am multiplying equation 1 by a2 and equation 2 by a1, right? So now I am eliminating xyz from these two equations. So for that it will become a1 a2 xyz plus b1 a2 yyz plus c1 a2 is equal to 0, and a1 a2 xyz plus b2 a1 yyz plus c2 a1 is equal to 0, right? If I am subtracting, then minus minus minus, it will cancel out. So it will be yyz times b1 a2 minus b2 a1 is equal to c2 a1 minus c1 a2, right? Or I can write yyz as c2 a1 minus c1 a2 on v1 a2 minus v2 a1, right? Also, now if I put this yyz in 1, so we will get xyz. Now from 1, that is a1 times xyz is equal to minus c1 minus b1 times yyz, that is c2 a1 minus c1 a2 on b1 a2 minus b2 a1, right? So by taking LCM it will be minus c1 b1 a2 plus c1 b2 a1 minus b1 c2 a1 plus b1 c1 a2 upon b1 a2 minus b2 a1. This is a1 times x by z, right? Or this b1 c1 a2, b1 c1 a2 will cancel out, and in numerator now I will take a1 as common in RHS, so that inside it will be left with c1 b2 minus b1 c2 on b1 a2 minus b2 a1, right? So from here I am getting xyz as c1 b2 minus b1 c2 upon b1 e2 minus b2 a1, right? So yyz is this and xyz is this, right? Now I can write yyz as, or xyz as, x upon c1 b2 minus b1 c2 is equal to z upon b1 a2 minus b2 a1, and also yyz as y upon c c2 a1 c2 a1 minus e2 c1 is equal to z upon b1 e2 minus b2 a1. So I can equate x upon c1 b2 minus b1 c2 is equal to y upon c2 a1 minus e2 c1 is equal to z upon b1 e2 minus b2 a1. And also I can write by taking minus sign common in denominators, so that it will become x upon b1 c2 minus c1 b2 is equal to y upon c1 e2 minus c2 a1 is equal to z upon a1 b2 minus b1 2, right? So but we are studying this thing in cross multiplication rule. So why this method is called cross multiplication? For this, let us take, for the time being, z is equal to 1. If z is equal to 1, then these two, then above two equations will become in two unknowns only. So then the system of equation will become a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0, right? And in that case, x upon b1 c2 minus c1 b2 is equal to y upon c1 e2 minus c2 a1 is equal to 1 upon a1 b2 minus b1 a2. So x will become b1 c2 minus c1 b2 upon a1 b2 minus b1 a2, and y will become c1 e2 minus c2 a1 upon a1 b2 minus b1 a2. So students, we can solve these two equations in two unknowns by using this method. And why we called it cross multiplication rule? So if I am taking, if I am writing the coefficients of x, y, z in the fashion p1, p2, c1, c2, a1, a2, and p1, p2 again, and writing denominator of x as p1 c2 minus p2 c1 for x, right? And for y, c1 e2 minus c2 a1, and for z, a1 b2 minus a2 b1. This is cross multiplication rule, right? But this is very important. Students, you should always remember this formula, because it it will save our time in complicated equations. When we will solve uh, simultaneous equations in class 10th, then this will give you great help while solving simultaneous equations, right? Now, let us take some questions. So question 1 is, find the ratio of x is to y is to z from the equations 7x is equal to 4y plus 8z and 3z is equal to 12x plus 11y. So students, if we have two equations in three unknowns, then we can only find ratio, right? Uh, so let us proceed according to cross multiplication rule. So first of all, I am writing this in a standard form, that is in RHS I am writing 0. So for this I am writing this as 7x minus 4y minus 8z is equal to 0 and 12x plus 11y minus 3z is equal to 0, right? Now x upon minus 4 into minus 3 means v1 c2 minus c1 v2, right, is equal to y upon c1 a2 minus a1 c2 is equal to z upon a1 v2 minus a1 a2, right? So this is x upon plus 12 plus 88 is equal to y upon minus 96 plus 21 is equal to z upon 77 plus 48, right? So this will be x upon 100 is equal to y upon minus 75 is equal to z upon 125, right? Or if I divide by 25, then it will be x upon 4 is equal to y upon minus 3 is equal to z upon 5. Or you can say x is to y is to z is equal to 4 is to minus 3 is to 5, right? In this way we can find ratio of x is to y is to z. Now let us take another question. Question is, eliminate x, y, z from the equations a1x plus b1y plus c1z is equal to 0, a2x plus b2y plus c2z is equal to 0 and a3x plus b3y plus c3z is equal to 0. So students, elimination means we have to find the relation between coefficients, right? So using again cross multiplication rule, we can take any two out of these three. If I'm taking 1 and 2, so using cross multiplication rule, we can write x upon, or from 1 and 2, x upon v1 c2 minus c1 b2 is equal to y upon c1 e2 minus a1 c2 is equal to z upon a1 b2 minus a1 a2, right? So this is x, y and z, ratio of x, y and z. So if I equate this as lambda, then x becomes lambda times b1 c2 minus c1 b2, y is equal to lambda times c1 e2 minus a1 c2, and z is equal to lambda times a1 b2 minus b1 e2, right? Now if I put these three in third, what I will get, x, y and z will eliminate if I use this step. So V3 times lambda times V1 C2 minus C1 B2 plus V3 times lambda C1 E2 minus E1 C2 plus C3 times lambda E1 P2 minus P1 E2 is equal to 0, right? So I can take lambda as common, and inside bracket it will be A3 times P1 C2 minus C1 P2 plus P3 times C1 E2 minus A1 C2 plus C3 times E1 B2 minus P1 E2 is equal to 0, right? And this is what? This is required eliminant, because in this relation there is no x, y and z. So students, for this class we are done. Let's meet in next class. Till then, bye bye, take care.